Mní Wičóni, in the language of my people, the Dakota, means water is life. This phrase was first thrust onto the national stage in 2016 during protests against an oil pipeline that was slated to run adjacent to many indigenous communities. While this phrase became a rally cry for their movement, I believe it captures the essence of my research quite well. Water is life, and for many, their livelihoods are in danger. In the next 25 years, 1/4 of the US is expected to face moderate to extreme water scarcity. This means for many people, taps, plumbing, and irrigation will all run dry. This future is only certain if we continue to rely on current water resources, with 70% coming from fresh surface water and 29% coming from fresh groundwater extraction. That last 1% encapsulates all of the current desalination capability we currently have in the US. Expanding that number is going to be key to providing water to future generations. And this is where my research comes in. When we start thinking about salty bodies of water we can access, the ocean usually comes right to mind. However, when you consider the 60% of the US population that does not live near the coast, we have to start looking elsewhere. Fortunately, salty groundwater wells are quite abundant in the continental US. The technology I research, electrodialysis, is used frequently to desalinate water from these sources. It is a membrane-based process in which an applied voltage drives dissolved salt removal. This voltage causes ions dissolved in the salty feed water to move around and become trapped in alternating channels, creating potable water and concentrated waste. Two factors that influence the energy demand of electrodialysis when using it for salty groundwater wells are well depth and temperature. Deeper wells cost more energy to pump to the surface, while warmer wells speed up ion movement during desalination, reducing the energy cost. To make things a bit more complicated, in real life, those warmer wells that we want to access are usually the deeper ones. To solve this, my research looks to create a model that considers these two factors and predicts the specific energy demand of an electrodialysis process for a certain salty groundwater well. This would be a useful tool for desalination engineers so they can make the most efficient process possible. Water is life, but I believe this phrase can also be used in reverse. We have to be fluid when we approach problems caused by climate change. My research into the temperature dependence of electrodialysis will help us use salty groundwater wells more effectively and sustainably. Thank you.